This video is about angles on the coordinate plane and how to convert angles to radian measure from degree measure. This first slide just illustrates what an angle looks like on the coordinate plane. I've shown you a 42-degree angle with a little black arrow to show you that I'm lifting off of the x-axis, which points at 0, to go up 42 degrees into the first quadrant. Let's define what the quadrants are. Quadrant 1 is the first place where we see positive angles. So I lift off with 0 and I end up somewhere between 0 and 90 degrees. I'm going to be in quadrant 1. If I go past 90 degrees, I'm going to be in quadrant 2, somewhere between 90 and 180. If I go past 180, I'm going to be in quadrant 3, between 180 and 270 degrees. And if I'm between 270 and a full circle, which is 360, I'm in quadrant 4. Now I can keep spinning around past 360 degrees, and I'll just cycle back through all the quadrants. Okay, but those are the quadrants. You're going to hear me talk about them a lot in this chapter to talk about where an angle is located. Let's define two important words here. So I'm looking at an angle. It's in the first quadrant. I don't have the degrees labeled because I'm going to move this angle around. But you do need to know that in standard position, which this angle is, the side pointing at 0 is called the initial side. Initial meaning like starting place. And the side where the angle ends is called the terminal side. Now in this case, my terminal side is in the first quadrant, so I might have an angle like 30 degrees or 35 degrees. I'm going to pick up that terminal side and rotate it in a counterclockwise direction, which is the way that we create angles. I could go further. This might be about an 80-degree angle. If I go straight up, I'm making a 90-degree angle. That's not in any quadrant. I could go past 90, this is about a 120-degree angle. If I drop it straight down, I've created a 180-degree angle, which is a straight line. If I go past 180, oops, I picked up the axis by mistake. If I go past 180, just pick up the corner. Past 180, this might be about a 235-degree angle. Straight down is 270 degrees because I've gone this direction, 270 degrees. I pick it up further, I can go maybe 300 degrees. I go all the way back around to point at 0. I've gone a full 360-degree angle. So I have to show you that blue curve so you know I traveled 360 degrees and not just stayed at 0. Okay? So one thing you'll be asked to do is draw an angle with that given measurement in standard position. So standard position means I'm going to have my initial side pointing at 0. And to get to my terminal side, I need to travel 240 degrees in a counterclockwise direction. So 240 degrees is going to be, I go 90, I go 180. I know if I get down to the y-axis again, I've gone 270, and that's too far. I don't want to go that far. I just need to go 60 degrees more. So I go 60 degrees more past 180, and I'm about here. And that's where I create my terminal side. So I've showed you the blue curve, and I would like you to show me a curve, too, on your paper to show me that you've gone 240 degrees in a counterclockwise direction. That's what my 240-degree angle looks like. To create a 500-degree angle, let's start with our initial side at 0. To get to our terminal side, we need to travel 500 degrees in a counterclockwise direction. So 500 is more than 360. I'm going to travel entirely around the circle. And then I need to go, if I'm at 360, I need to go 140 more degrees to get to a 500-degree angle. So 140 more degrees is going to look like here, which would be 90 more. And then I need to go about 50 more than that. So I'm going to end in quadrant 2, create my terminal side, and that blue curve loops all the way around to show me I've traveled 500 degrees from my initial side. To create a negative angle, I'm still putting my initial side at 0, but instead of going counterclockwise, I'm going to head south, go in a clockwise direction from here. 50 degrees negative is going to end up in the fourth quadrant. It's only 50 degrees, so it's not even to the first axis. And I create my terminal side right there. That little blue arrow shows me I've gone negative 50 degrees. Another important vocabulary word to define is coterminal angles. Coterminal angles are angles whose terminal sides overlap. So it says, think about going a full 360 degrees in either direction to end up back where you started. That's what coterminal angles look like. So let's say I have a 45-degree angle here. It's in the first quadrant, and this is the direction I've traveled. positive 45-degree angle. If I then took that terminal side and rotated it a full 360 degrees back around the circle, you would agree that I would end up right where I started, right? Only it's not a 45-degree angle anymore because I've gone around another entire circle. So we would say that the 45-degree angle is coterminal with the 405-degree angle that I then created, right? How did I get 405? By doing 45 plus 360 degrees, right? Which is 405 degrees. And I could keep going even further, rotate it another 360. I would get a 765-degree angle, right? That would also be coterminal with 45. So there's an infinite number of coterminal angles. I could just keep spinning that terminal side 360 degrees around. I could even spin it 360 degrees around in a clockwise direction and get a negative angle that's coterminal with it. So let's talk about calculating these coterminal angles. So if it's asking me for one positive angle and one negative angle that's coterminal with the given measurement. So let's do example A first. So in example A, I'm given a negative 45-degree angle and asked to find a positive coterminal angle with that. So to find my positive one, I'm going to add 360 degrees to my starting point until I get to a positive angle. If you do negative 45 plus 360, you will get to a positive angle that's coterminal with negative 45 at 315 degrees. That answers part of the question. To get a negative that's coterminal with it, I'm going to start at my negative 45 and I'm going to go the other direction around the circle, subtract 360 degrees to end up at negative 405, which would also be coterminal with a negative 45-degree angle. And now I've answered that question. Let's do it again with a 395-degree angle. 395 is where I'm starting. To get one that's positive, this is a special case because I'm starting at 395. I can either add 360 to that. That would certainly be positive and coterminal. Or I could subtract 360 from it. That would still be positive because this number is so large. For the sake of consistency, I will add 360 to it. So I'm going to start at 395. I will add 360. Go on another lap around. Gets me to a 755-degree angle. That would be coterminal with 395. To get to a negative, if I'm starting at 395 and I want to get negative, I'm going to have to subtract 360. But that's not going to be good enough. That's only going to get me down to 35 degrees. But I need to be negative, so I'm going to have to subtract another full circle from that to get down to a negative coterminal angle. So if you subtract another 360 from 35, you end up at negative 325 degrees. And that would be a negative coterminal angle with the original 395 that we started with. Radian measurements are another way of measuring angles. So we've been using degrees for our whole life to talk about angles, right? A 0-degree angle, a 90-degree angle, a 180-degree angle. Angles can also be measured in radians, which we're going to use a lot in this chapter on trig. A radian, instead of being related to the degrees in a circle, it's related to the circumference of a circle with a radius of 1. You don't need to worry so much about where radians come from, but you should know that 0 radians is still pointing this direction, right? Just same place where 0 degrees would be. Pi radians is exactly 180 degrees. So pi is a radian measurement that is equal to 180 degrees. Pi and 180 degrees mean the same thing, which means that halfway between 0 and pi, we have half of pi, also known as pi over 2. Pi over 2 is the radian measurement that is equivalent to a 90-degree angle. And then if I have each quadrant represents going pi over 2, going another pi over 2, going another pi over 2, then down here, what used to be 270 is called 3 pi over 2, because I've gone 3 complete 90-degree rotations to get down to there. And since we know 90 degrees is pi over 2, it makes sense that this would be 3 pi over 2. If you got back to 0 going all the way around the circle this direction, you would reach 2 pi. So 2 pi is what we're going to use to represent a full 360-degree rotation in radians. So radian measurements all have pi in them, unless you were to take out a calculator and actually put pi into it, like as 3.14, and you could get a decimal measurement for your radians, but most often we'll leave it in terms of pi. So to convert between degrees and radians, it's a very simple conversion process. If you're trying to go from degrees to radians, you're just going to multiply your degree measurement by pi over 180. It's a conversion because pi is 180 degrees. So in example A here, I'm going to take my 125 degrees, convert it to radians by multiplying by pi over 180. This is really just multiplied by 1, since pi is equivalent to 180, like I keep saying. When I do this, I really just need to reduce my 125 over my 180. So what this comes out to is 125 pi, we're going to leave it in terms of pi, over 180. And then you have to reduce your final fraction into simplest terms. So both of these are divisible by 5. And what this comes out to is 25 pi over 36. That can't be reduced any further. So that's the equivalent of 125 degrees in radians. To go the other direction, to go from radians to degrees, we're just going to flip that conversion fraction upside down, multiply by 180 over pi. So if I'm starting from, this is example B here, if I'm starting with a negative pi over 12, trying to go to degrees, I'm going to do this so that my pi's will cancel out and I'll be left only with degrees. So the pi's cancel each other out. I'm left with negative 180 over 12. And then I want to see if I can either reduce or divide that. Does 12 go into 180 evenly? It does. This is the equivalent of saying negative 15 degrees. That's as simple as that one can get. Okay? And that's how you do conversions between radians and degrees. It just depends on the whether pi is on top and 180 is on bottom, or 180 is on top and pi is on bottom.